Assalamu alaikum warahmatullahi wabarakatuh. Welcome everybody. In this video, we'll start with chapter 5 on hardware component of programmable logic controller. In chapter 4, we had an introduction to PLC. We learned the difference between PLC and personal computer, and also we learned the structure of PLC and the main component of PLC and their functionalities. This chapter actually focus more on the details of PLC hardware components before we move to talk about the PLC software components in the next chapters. So these are the expected outcome of this chapter, and here is the main reference for the chapter 5. Actually, from chapter 4 and forward, we are going to focus more on the programmable logic controller textbook. These are the main content of this chapter, which start with the input-output section, then central processing unit, CPU, and also programming terminal devices and human-machine interfaces. In the first section, which is input-output section, actually, when we talk about the PLC structure in the previous chapter, we see how these input-output interfaces are used to connect between the controller unit and the field devices. So we said the input interface is usually connected with the sensors, switches, and device which connected as the input to our control system. And the output interface is connected to the actuators. And usually these two modules are very important because they use to translate the signal that they receive from the field or send to the field. And for the input modules, for example, they receive the signal from the sensors and switches and convert the signal into signal which is understandable by the microcontroller. For the output modules, actually, it takes the signal from the microcontroller or from the CPU and send it to the actuator or output devices. So we have actually two main types of the PLC input-output modules here, which is discrete and analog. But we are going to talk in details about each type and what is the difference between the discrete input-output modules and the analog input-output modules. Here, as we can see here, we have two types of the PLC we already mentioned in chapter 4. One is the fixed type, one is the modular type. So the fixed type PLC or the small PLC here we see we can find the input-output interface. Here is the input, for example, and here we can see the output. So usually the fixed PLC, it has its pre-implemented or pre-installed input-output sections. So these input modules and output modules here are connected to the input devices and to the output devices, and the number of terminals for each module here are fixed and cannot be changed or extended. For the modular type here of the PLC, we can see that here we already see some or similar hardware in the previous chapter actually. So which we said it's going to include the power supply, to include the CPU module, and here we have the input-output interfaces. So this type of interface or the input-output interface are modular type. So modular type here, it can be plug and fixed into the PLC. So in the case of some of these modules are damaged or got a problem, we can easily change this module or that module and replace by a new module. So this we call it the modular type, and this one we call it the fixed type. Usually the fixed type or this type of PLC used with the small PLC system. Here for the modular one, it can be extended with more input output sections here. For that, it's used with the bigger PLC systems. So this is the difference or the main definition for the input interface modules and the output interface modules here. So for the input modules here, it's accept the signal from the machine or process device. When we say accept the signal, that means these modules actually is responsible to receive the signal from the sensors or from the switch or from any type of input devices, either analog or discrete devices. Then it will forward the signal or the received data from this sensor or from this switch to the CPU unit or to the microcontroller unit. Then the output modules here, it will take the signal or the order or the command from the controller, and it will convert it into a suitable signal for the actuators. So for example, if I have an analog actuator here which required analog signal, this output interface should have a digital to analog converter in order to convert the signal to a suitable signal to run the output devices or to send the command from the controller or from the CPU unit into the actuators. So there is in the case of the big PLC system or the super PLC system, actually, we may need to use a lot of input output devices, a lot of input output modules. So in that case, instead of implement all the input output interface in the control room, or in the main beside the main server to control the unit or to control the process with the processor, we are going to place some of these modules near to the process in the field. So why we need to do that one? Because when we place it in the field here near to the near to the process unit, for example, I want to use the PLC to control this process here. So this process includes some sensors, include also some actuators, motors, and so on. So instead of place this PLC input output modules beside the processor unit in the control or in the main control port, we are going to place it near to the process here, so we can save the wiring that we are going to use to connect between the process and the input and output interfaces. So in this case, we call it remote rack or remote PLC rack. So that type of PLC here or that type of PLC rack, we call it the remote rack. Why? Because this only include input output modules. It doesn't have any CPU unit. As you can see here, it has power module, it has input and output, and it has communication modules here. So the communication modules it will use to send the signal or to connect between the remote input output modules here or in the remote rack with the original or with the main rack or with the main system or the local PLC system that include the PLC or the microprocessor unit or the processor unit. So in this case, instead of use CPU here and CPU in the field, we are going only to use that we have only one CPU here, and we are going to you instead of sending or connect many wires from this process to the control room, we are going to connect only one wire from this remote rack into the main or to the local rack of the PLC system. Actually, since we have many devices as input like sensors or switches and so on, and we have also many devices for output which connect to the PLC like actuators or pilot light and so or any other devices of the actuators that we are going to use to control our process. So it's difficult to the PLC to understand this signal come from which sensor or this signal come from which actuator or go to which actuator. In order to simplify this process and make it smooth between or correct or accurate or reliable communication between the device and the CPU unit, we need to use address or labels. So address here or labels will be used to name every device that we are going to connect to our PLC system. So if I have 100 sensor, I should have 100 address. Each sensor has its own address. If I have 100 actuators, I should use 100 address for our actuators and so on. Okay. So this address or label, we use it to name our devices, and then we connect or we define these names inside the software or the program that we are going to use inside our CPU of the PLC. So here, for example, here we have this instruction represent the input, so we need to name it as input. this instruction is connect to the terminal number 2, so we put number 2 here, or slot is existing in the slot number 2, so we put number 2 here. So this connect to the terminal number 0, for example, we put it number 0. So the address, for example, in this case will be I input to slot number 2, 0 is the terminal number. So actually there are three type of addresses here that usually use with the PLC system. The first type we call it rack slot based. Rack slot based here, or rack slot based addressing scheme, is used with Allen Bradley SLC 500 controller. So if you see SLC 500 controllers, you should know that this type of controller usually use the rack slot based, and this is the rack slot based addressing. It looks like this one. It has address, is it input or output, I or O. Then we have the slot number and we have the terminal number. So this we call it rack number slot based addressing. The second type of addressing here, we call it the tag based. So the tag based here, which is usually used with the Allen Bradley control logics controller. So this type of controller, or this type of controller of PLC controller, is usually used the tag based. And as you can see here, this is the tag based addressing. So you can see here the name fan motor. You can see here the name fan motor, and you have also here controller memory tag data here, base tag data, and so you are going to see the text. But in this address there is no text, only you have the type of input or output, the slot number, and also uh, uh, the terminal number. But here we have some type of text or alias tag. So this alias tag, if you have a sensor, for example temperature sensor, you are going to see the name is temperature sensor. Pressure sensor, the name is pressure sensor. But under this alias tag you have some addresses which is automatically generated when you implement or you install the PLC system. So for example, here you have local to o data.5. Here you have local to o data.5. It means this type or this tag, it's already, or it's automatically configured during the installation of PLC. But these names will be given by the programmer for the PLC system. The third type of addressing here is the PC based, and this type of addressing usually used with the software. With the simulation of the PLC. It's not for the hardware component. Usually there is some interface which is implemented for on the PC, on the normal PC, to simulate real PLC. So this type of addressing is used with it. PC based, since it is implemented on the PC. It's not in the CPU of the PLC system or the hardware PLC system. So these are the three main types of addressing. You should know how to write the address by using the rack slot base, or by using the tag base. What is the difference between rack slot base and tag slot base, and so on. So here we have some examples for several addresses for the SLC 500 rack slot base, which is the first type of addressing here. You can see here this address actually will be used either on the in the memory, or on when we define the software inside the CPU, it will be also known by the memory to address the place of the data. So the memory or the CPU, the PLC, can access to this data later when it's called from the user or from any operator. So as we can see here, for example, here this first address, it is O4/15. So the first one, O or I, it should indicate is it input interface or output interface, because we said we have two type of interface, input and output. The input is connected with the sensors, the output is connected with the actuators. So when we see output here, O, so that means it is output modules in slot number 4. What we mean slot here? How many slot do we have here? For example, this is the CPU slot, but after that we have some slot for input output model. So if this, for example, slot 0, slot 1, slot 2, slot 3, slot 4, slot 5, and so on. So the number of, or the number of slot, it will be included in the address here. So because we are going to use, for example, slot 4 and bin or terminal 15, but we have another sensor will connect to slot 3 terminal 15, slot 2 terminal 15. So how we can differentiate between the different 15 terminals here by using the slot number. So slot number 4, terminal number 15. For the second address here, I38. So I is for the input here. I means its input module, and 3 means the slot number 3, and 8 means the terminal number 8. 060, I mean 060 here, that it is output slot number 6 and the terminal number 0, and so on. So this, you should know how to convert this type of SLC 500 rack slot from text into address, or from address to the text. Actually, as we said before, the address will be will not only be for the device in the field, also it will be included in the software and also in the memory to call the numbers, or to call the data later on. Okay, so for example, here we have this two switch as input device, and we have this one, the motor, or an actuator here is connected to the as output device. Okay, so for the input device here we have two inputs. Each one will have a different address. So the first one, it has the address, for example, I input slot number 1, terminal number 0, while the second one will be input slot number 1, terminal number 1. So both of them are on the same slot, which is slot number 1. This is slot number 1. It has how many terminal here? It looks like 16 terminal, for example, or it has 8 terminals, or it has 32 terminals, 64 terminals. It depends how big is this interface. Okay, so for that, the numbering usually start from 0. So you can see here, this is terminal number 0, that one is terminal number 1, and so on until 15 here. If it's 32, it will be until 32, 64, and so on. Okay, so you can see here, this is the address on the hardware device. It's identical with the address here inside the memory. Okay, so we have the processor memory here. So in the memory here, we have, is it input or output? This side actually is more for the input. Actually, this side is for the input, and the other side is for the output. When we talk in this part, all this part more on the input side, and this part is more on the output. So both are inside the controller. Actually, all this part is inside the controller, or the processor unit and CPU unit, and memory also. So you can see here, the terminal number 0 is connected the same address, it's input 10, but what is the status of this switch now? Is it closed or open? If it is closed, it will be 1. If it is open, it will be 0. Now this one is closed, so it's connect. So you can see here what is the status here, or the bit, this we call it the bit address, or bit based addressing. So you can see here bit. What is the status of the bit here? Is it 1 or 0? Is it on or off? So it is 1 because this switch is closed. You can see the second switch here. The status of the switch is open. So the status of the bit here is 0. That means this address, which is I11, which is referred to the switch number, the switch connected to the terminal number 1 in the slot number 1, is open now. If this switch is closed, the status of this bit inside the memory should be 1. If this switch is open, the status will be changed to 0. For that, the controller will understand what is the status of the input device here. So you can see here also in the software inside the program file, this is inside the program file, you can see here for the first one, since it is 1, so you can see green line here, or green highlight. This green highlight indicate that, for example, the status, or the status of the instruction is closed, or this is examine if closed, so yes, it is closed. The second one, examine if open, no, examine if closed, is it closed? No, it is open, so there is no highlight here, no highlight in this part. That means this instruction is off or 0. Okay, since we have here 0 and we have here 1, that means 0 and 1 will give you 0, because the output will not energize. The output coil here will not energize, so we can see the output is 0. Since the output here is 0, so here output is 0 for the memory. Since the output of the memory is 0, it will give the order to the actuator to be off, or to become 0 in the in the off state. Okay, so we already have, for example, how to check the status of this instruction in chapter 4. Here it's the same. So in the case of this one, or this switch changed to 1, so now we have 1 1, this become 1, this will we have 1, then the output address become 1, and the output actuator will be switching on. So a bit is a binary digit that can be either 1 or 0. So we have here 1 for the close, 0 for the open. For this, actually, for the discrete input, when we say discrete input, means we are talking about binary input. Binary means either 0 or 1, no other value in between. Okay, so this is the discrete input output device. For the analog input output device, we usually use the word instead of using the bit. Here we said we use the bit for addressing, so we can see the bit status here 1 or 0. But for the analog input output device, the address will be word. What is the difference between analog input output and discrete input output? The discrete one is give you only two options, on or off, like switch. So the switch is discrete because it will give you on or off. But if I have temperature sensor, for example, so the temperature sensor will give you a range of values, as we learned before in chapter 1. So if you have analog sensor, it will give you a range of value based on the transfer function. So the value of temperature, for example, will change from 0 to 100. So you are not have only two value. We have maybe 100 values. You have thousands of values. So this we call it analog. So in this case, one bit is not enough to represent the data of the input. So we are going to use the word here. So the word consists of multiple bits, not only one bit level. This for that here, it is the main differences between the bit level addressing and the word level addressing. So this is the definition for bit level addressing and word level addressing. In the case of the analog input here, we have, for example, thermocouple. Thermocouple is a type of temperature sensor that we learned before. So this thermocouple will connect to the input terminal here. One input is positive, one input is negative. Okay, so the address of this one will be I input slot number 1, and it will give you 2.0 here. It's not like the previous one, only 0 or 1. No, here it is 2.0. Okay, so in this case, it will give you a word. It can be 2, it can be 3, 5, and so on. Okay. The same is in the case is for the analog output models. So it will also give you the output device here to or send the output to the output device. Here is a difference between the third or the more details about the tag-based addressing. So we said the tag-based previously, we said it has one alias which is used by the developer or the programmer. So he write to define what this instruction represent. For example, he said here start push button, for example. It is the definition here. This definition is written by the developer who developed the program for the PLC. But this address, which is local sex data and so on, this actually generated automatically when you install your new microcontroller or new PLC system, CPU units. Okay, so the difference between the two type of the rack or slot rack slot based and the tag based. The rack or the tag based, we need to define what is the name. Is it temperature sensor? So we need to write this is a temperature sensor. It's a temperature sensor, so we need to write a pressure sensor. If it's a motor, we write a motor and so on. So all the field devices here are assigned tag names to define their names. So it is easy for the programmer or the developer later on to find. I have one sensor got problem. What is the type of the sensor? It is temperature sensor. So he can find it in the program or the developed program inside the CPU of the PLC system. This is a comparison between rack slot based addressing and tag based addressing. So here on the left and on the right, it is the same. Actually, we have the same system, but in the left system, we use the rack slot based addressing. In the right, we have the equivalent tag based addressing. Okay, so already mentioned before, in the rack slot, we need to highlight the type of interface, is it input or output, then we need to highlight the number or the what is the slot number, then what is the device number. So you can see here I111, I12, I13, O21. O21 is the output here, and these three represent the input. This is for the slot based addressing or rack slot based addressing. But for the case of the tag based addressing, we need to define here what is I11. And he said his I11 is a pressure switch, so we need to write here pressure switch, and this address will be generated automatically. What is the type of the second instruction? It is temperature switch, so we are going to write here temperature switch, and this is the address is automatically generated. The third one is the manual push button, so this will be the manual push button or with its address it, and also sorry, this is the manual push button, and also here is the mixer of our output of your control or your PLC system. The third type of addressing, we said it is PC based, and we said it's usually used with the software or with the PC with an interface. You can see here, this one is a card or interface which is integrated or installed in the PC or in the personal computer to simulate the real PLC system. So in this case, when you have such card and you implement or install in your PC and you are going to run some software for PLC, so in that software you need to use the PC based addressing just to simulate the real PLC system. Some input output model are come in one model. For example, it's like a combination of input output modules, so can have both input and output connection on the same modules. So for example, here on the left we have input, on the right we have output. Even it's plug-in model or modular type, so but it's come together, input and output, input in one side, and this input or will be connected to the input devices like sensor, switch, and so on. And here this will be connected to the output device actuators like light, motors, servo motors, stepper motor, and so on. This is how the input output modules looks in real from the side view. This is a practical one actually from this Allen Bradley. So you can see here on the left side we have a circuit or the electronic circuitry here, and this electronic circuitry actually represent the so usually we use, as we mentioned in chapter 2, we have something we call it the signal conditioning circuit. So usually the signal conditioning circuit are placed on this part or on this port. Okay. In addition to the main connection or the main interface between the input devices and the output device. In this part here of the module, we have the terminals. We need to connect the terminal for the device. So the sensors, actuators, or connect. Sorry, the sensors in the case of input, the actuator in the case of the output will be connected to this terminal. When these terminals are connected here and fixed, this whole part can be removed. So it will be plug and play. Just it will be removed, then it can be plugged to the PLC system to run it or to make it in surface. Here we have the status lights, and as we mentioned before, the status of light here is a good indicator to show you which sensor is in surface. So it will be, for example, a green light, which sensor has a problem. So for example, it will have red light. So this LED actually used to show you or indicate what is the status of the real circuit in the field. This is just a 3D representation for the module and or the PLC modular PLC, and you can see here this is the empty place. In this empty place, we are going to plug our model, same like this one. So this model is just it's come with already with the terminal here with the wiring to the sensor or to the actuators. So it just plug in inside this one. So it will connect with the rear or the in the back of this module or of this rack. It has a connection between different modules, either for input output, for CPU, for communication, for power, and so on. Also the power here come to the devices from these terminals or from this boards. If any of these modules got a problem, so it can be easily removed and replaced by new modules. Usually the price for these input output models is much cheaper than the price of the CPU model or the power model and so on. We have different size of input output modules. So this it can be 8, 16, 32, 64 as I mentioned earlier. So it depends on how big is your PLC system. So you are going to select the reasonable or the suitable type or the suitable size of the input output modules. So it has, for example, the small one, it has 8, for example, the big one, it has 32, I mean 64 and so on. So the high density 64 type will provide a greater space saving with less rate current output per output. Means you have meaning for I have 64 terminals. I'm going to connect to 64 output or input devices. Since 64 devices, that means it will the power of this model will be distributed among all these 64 devices. We'll continue in the next video.